చాలా భయం. మ్యాథ్స్ ఎగ్జామ్ వచ్చిందంటే చాలు చాలామందికి ఒంట్లో వణుకు పుడుతుంది. అటువంటి మ్యాథ్స్ సబ్జెక్టులో అతి చిన్న వయసులోనే ఎన్నో ప్రయోగాలు చేయడమే కాకుండా సొంతంగా సిద్ధాంతాలు రూపొందించడం చేసి అందరినీ ఆశ్చర్యపరిచేవాడు. ఆ వయసులో ఆయన వేసిన ప్రశ్నలకు ఉపాధ్యాయులు కూడా సమాధానం చెప్పలేకపోయేవారు. ఆయన పేరే శ్రీనివాస రామానుజన్. 20వ శతాబ్దంలో ప్రపంచ ప్రఖ్యాతిగాంచిన గొప్ప గణిత మేధావుల్లో ఒకరు. గణిత శాస్త్రంలో ఆర్యభట్ట, భాస్కరాచార్యుల తర్వాత భారతదేశానికి పేరు తెచ్చిన గొప్ప మేధావి శ్రీనివాస రామానుజన్. ఆయన జీవిత విశేషాలను కొన్నింటిని మనం ఈ వీడియోలో తెలుసుకుందాము. శ్రీనివాస రామానుజన్ తమిళనాడు రాష్ట్రంలోని తంజావూరు జిల్లా కుంభకోణం దగ్గర ఈరోడ్లో నిరుపేద బ్రాహ్మణ దంపతులకు 1887 డిసెంబర్ 22న జన్మించాడు. ఆయన తండ్రి కుప్పస్వామి శ్రీనివాస్ అయ్యంగార్ ఒక చీరల దుకాణంలో గుమస్తాగా పనిచేసేవారు. తల్లి గృహిణి. శ్రీనివాస రామానుజన్ 1892లో కుంభకోణంలోని ఒక వీధి బడిలో తన ప్రాథమిక విద్యను ప్రారంభించారు. ఆయన తన 10వ ఏటనే ప్రైమరీ విద్యాభ్యాసంలో ఎంతో తెలివైన వాడిగా పేరు తెచ్చుకున్నాడు. పై తరగతి పిల్లలు కూడా ఇతని వద్ద లెక్కలు చెప్పించుకునేవారు. ఇటువంటి లెక్కనైనా చిటికలో చేసే రామానుజన్ పెద్ద సంఖ్యలలో గుణకార భాగహారాలను మెదడులోనే చేసి టీచర్లను అబ్బురపరిచేవాడు. గణితం అంటే ప్రాణంగా భావించే రామానుజన్ జ్ఞాపక శక్తికి అందరూ ఆశ్చర్యపోయేవారు. రామానుజన్ తన 13వ ఏట లోని రాసిన త్రికోణమితి గ్రంథాన్ని లైబ్రరీ నుండి తీసుకుని దాన్ని పూర్తిగా అర్థం చేసుకున్నాడు. ఆ తర్వాత కార్ రచించిన మ్యాథమెటిక్ బుక్ చదివి తన స్వంత ఆలోచనలతో సిద్ధాంతాలను, సూత్రాలను అభివృద్ధి చేసుకోసాగాడు. రామానుజన్ తన 16వ ఏట మెట్రికులేషన్లో ప్రథమ శ్రేణిలో పాస్ అయి కుంభకోణం గవర్నమెంట్ కాలేజీలో స్కాలర్షిప్ పొందాడు. ఆ తర్వాత ప్రభుత్వ కాలేజీలో చేరి గణితంలో ప్రథమ శ్రేణిలో మార్కులు పొంది మిగతా సబ్జెక్టులో ఫెయిల్ అయ్యాడు. దాంతో స్కాలర్షిప్ పోయి కాలేజీ చదువు ఆపేయవలసి వచ్చింది. రామానుజం నిత్యం గణితంలో నిమగ్నమై ఉండేవారు. దాంతో అతని తల్లిదండ్రులు అతన్ని ఎలాగైనా దారిలోకి తీసుకురావాలని 1909వ సంవత్సరంలో రామానుజంకి తన 22వ ఏట జానకి అమ్మల్ అనే బాలికతో వివాహం చేశారు. 1910వ సంవత్సరంలో గణితంలో బాగా పరిశోధనలు చేసి 2 పుస్తకాలను ప్రచురించి గణిత శాస్త్ర సమాజాన్ని ఏర్పరిచిన రామస్వామిని రామానుజం కలుసుకుని వాటిని చూపించారు. అవి అతను బాగా నచ్చాయి. దాంతో ఆయనకు అకౌంటెంట్ జనరల్ మద్రాస్ ఆఫీసులో ఒక చిన్న క్లర్క్ ఉద్యోగం దొరికింది. రామానుజం ఉద్యోగంలోకి చేరిన ఖాళీ సమయాల్లో గణిత శాస్త్రంలోని చిక్కుముడులు నిప్పే ప్రయత్నం సాగిస్తూనే ఉండేవారు. ఇండియన్ మ్యాథమెటికల్ సొసైటీ మ్యాగజైన్కి రాసిన వ్యాసాలు ఆయనకు మద్రాసులో గొప్ప పేరు తెచ్చిపెట్టాయి. ఆ వ్యాసాలు కేంబ్రిడ్జ్ విశ్వవిద్యాలయ ప్రొఫెసర్ జేహెచ్ హార్డీ దృష్టిని విపరీతంగా ఆకర్షించాయి. ఆ వ్యాసాలు చదివిన ప్రొఫెసర్ హార్డీ రామానుజంను ఇంగ్లాండ్కి రమ్మని ఆహ్వానించారు. అలా 1914 ఏప్రిల్ 15న రామానుజం ఇంగ్లాండ్ పయనమయ్యారు. ఇంగ్లాండ్లో జేహెచ్ హార్డీ, రామానుజం ఇద్దరు గణిత అంకెలు, వాటి ప్రభావాలపై ఎడతెగని చర్చలు జరిపేవారు. ఆ అంకెలపై రామానుజం నైపుణ్యం చూసి గణిత శాస్త్ర మేధావిగా హార్డీ ఆయనను గుర్తించారు. ఇంగ్లాండ్లో విపరీతమైన చలి వల్ల, సరిగ్గా తినకపోవడం వలన, నిరంతర పరిశోధనల వల్ల రామానుజం ఆరోగ్యం రోజురోజుకి క్షీణిస్తూ వచ్చింది. అయినా కూడా ఎంతో పరిశోధన చేసి 32 పరిశోధనా పత్రాలు సమర్పించాడు. ఆయన ప్రతిభను గుర్తించిన కేంబ్రిడ్జ్ విశ్వవిద్యాలయం 1916వ సంవత్సరంలో అతనికి BA పట్టాను ప్రదానం చేసింది. 1918వ సంవత్సరంలో రామానుజన్ కృషిని గుర్తించి లండన్ రాయల్ సొసైటీ సభ్యత్వాన్ని ఇచ్చింది. అదే సంవత్సరం అక్టోబర్లో ట్రినిటీ కాలేజీ ఫెలోగా ఎన్నికయ్యాడు. ఆ గౌరవాన్ని దక్కించుకున్న మొదటి భారతీయుడు రామానుజన్. రాను రాను రామానుజన్ ఆరోగ్య పరిస్థితి విషమించడంతో 1919 మార్చిలో భారతదేశానికి తిరిగి వచ్చేశారు. ఒక పక్క ఆరోగ్యం క్షీణిస్తున్న తన పరిశోధనలు మాత్రం మానలేదు. చివరికి రామానుజంకి ఇన్ని వైద్య వసతులు కల్పించినా ఆయన కోలుకోలేకపోయారు. దాంతో ఆయన 1920 ఏప్రిల్ 26న తుది శ్వాస విడిచారు. రామానుజన్ గణితంలో ఆయన సాధించిన విజయాలకు గుర్తుగా ఆయన జన్మదినమైన డిసెంబర్ 22న మ్యాథమెటిక్ డేగా మనం జరుపుకుంటాము. 1962వ సంవత్సరంలో ఆయన 75వ జన్మదినం నాడు సంఖ్యాశాస్త్రంలో ఆయన చేసిన విశేష కృషిని కొనియాడుతూ స్మారక తపాలా బిళ్లను భారత ప్రభుత్వం ప్రకటించింది. రామానుజన్ చిన్న వయసులోనే 33 సంవత్సరాలకి తనువు చాలించకుండా ఉంటే మరెన్నో గణిత శాస్త్ర అద్భుతాలను చూడగలిగే అదృష్టం మనకు దక్కి ఉండేది. ఇది ఫ్రెండ్స్, మ్యాథమెటికల్ జీనియస్ శ్రీనివాస రామానుజం జీవిత విశేషాలు కొన్నింటిని మీకు తెలియజేశాను. ఓకే ఫ్రెండ్స్, ఈ వీడియో మీకు నచ్చింది అనుకుంటున్నాను. మీరు కనుక నా ఛానల్ని సబ్స్క్రైబ్ చేసుకోకపోతే కనుక కింద కనిపిస్తున్న రెడ్ కలర్ సబ్స్క్రైబ్ బటన్ మీద క్లిక్ చేయండి. అలాగే ఈ వీడియోని అయితే లైక్ బటన్ ప్రెస్ చేయండి. మీ ఫ్రెండ్స్కి ఫేస్బుక్, గూగుల్ ప్లేలో షేర్ చేయండి. మీ అభిప్రాయాలు కింద కామెంట్ రూపంలో పోస్ట్ చేయండి.
Hi, welcome dear students. Today's new topic is on logarithms. and logarithmic inequalities. Right? How a logarithm is defined, basically, how it works out. Now let us see that. Right, my dear students? Now, the logarithm of a function, how it is defined, now let us observe that. How it is defined generally, if a power x is equal to n, then log n to the base a is equal to x. In this way, the exponential function is converted into logarithm. If a power x is equal to n, then log n to the base a is equal to x. Here, a is called the base. A always greater than 0 and a is not equal to 1. And n is also logarithm of some number, is always positive. Why means you can easily guess that whenever a is greater than 0 and a is not equal to 1, here, right, a is positive. Positive power any real number, okay, will give you a positive value. That's why logarithm of n to the base a is equal to x. N is always positive and a is positive. If a is positive, n happens to be positive, right? That's why these conditions we are having to define logarithm of a function, right? Now you can illustrate this conversion using some examples, like if 2 cube is equal to 8, that we can convert into log 8 to the base 2 equal to 3. 2 power 4 is equal to 16, that we can convert log 16 to the base 2 equal to 4. And 3 square is equal to 9, that means log 9 to the base 3 equal to 2. If we have 5 square equal to 25, log 25 to the base 5 is equal to 2. Like that we will use it. 2 power minus 2 equal to 1 by 4, then log 1 by 4 to the base 2 equal to minus 2. Like this we can convert these exponentials into logarithms. And now let us see here how to convert logarithms into exponentials in the same way, like this. Suppose you have something like log 1 to the base 2 is equal to 0. That implies 2 power 0 is equal to 1. See, log 1 to the base 2 equal to 0, then 2 power 0 is equal to 1. Next, we have something like log 100 to the base 10 is equal to 2. That means 10 square is equal to 100. 10 square is equal to 100. We can write like this. And okay, like that, plenty of things we have here. Log 27 to the base 3 is equal to 3. That means 3 cube is equal to 27, like this. Like that we can have plenty of the things, like suppose you have log 1 by 2 to the base 2 is equal to minus 1. That means 2 power minus 1 is equal to 1 by 2. Okay, finally you have something like log 1 by 100 to the base 10. You have this equal to minus 2. That means 10 power minus 2 is equal to 1 by 100. Like this we can write. Right, my dear students? Now we have a nice definitions: common logarithms and natural logarithms. There are two types of logarithms. We have, one is common logarithms. Logarithms which are to the base 10 are called common logarithms, right? For example, log 2 to the base 10, log 5 to the base 10, log 20 to the base 10. When you have base 10, then you can call them as common logarithms, etc. we have. Now natural logarithms. Logarithms which are to the base e are called as natural logarithms. For example, we have log 2 to the base e. This is also called as ln2. Log 5 to the base e, ln5. Log 20 to the base e, ln20, etc. For example, ln x means log x to the base e. Ln x means log x to the base e. Right? Okay. Common logarithms are the logarithms which are to the base 10, and natural logarithms are the logarithms which are to the base e. Right? Okay, fine. Now we are going to discuss some of the results which are based on these logarithms. Now we have some set of results that we are going to discuss, right? The first one is log 1 to the base a is equal to 0. That we can do very easily, right? How we are going to do that, like the proofs, these become very simple. Like first one, you know that a power 0 is equal to 1, and we know the base of the logarithm will satisfy these conditions. A is greater than 0 and a is not equal to 1. When a power 0 is equal to 1, right, and a is not equal to 1 here, right? In this, now if you convert this into logarithm, now you have log 1 to the base a is equal to 0, like this. Log 1 to the base a equal to 0. Hence we got the first result. Now the second result, you know that a power 1 is equal to a under the same conditions. That if you convert into logarithmic form, now if you convert into logarithmic form, log a to the base a is equal to 1, like this. A to the base a is equal to 1. Therefore you got the second result. Now the third one, we know that a power x is equal to n. That means now only we defined how the logarithm log n to the base a is equal to x, right? Now you take a power x is equal to n. That implies a power x, now only we have got x is what? Log n to the base a. This is equal to n, like this. Therefore you have got wonderfully this result. The third result also you have got from this, right? Like this we have got some more results that we are going to discuss. These are the fundamental blocks and which are used to do different kinds of problems in logarithms. Now the fourth result, log mn to the base a, that equal to log m to the base a plus log n to the base a. Let us take the left hand side, how we will be proving this. Log mn to the base a is equal to, you take p, that means a power p is equal to mn. You call it as equation number 1. Now you take this one, log m to the base a as q. That implies a power q is equal to m, right? And you take log n to the base a, that equal to r. That implies a power r is equal to n, right? Now you have got a power p, okay, from the first one, that equal to m into n, that equal to a power q into a power r, that equal to a power q plus r. Now you see, my dear students, a power p is equal to a power q plus r. That means bases are equal. You can equate the powers, exponents. That means p is equal to q plus r you will be getting. P means what? Actually, p means we have taken this, right? Log mn to the base a, that equal to q. Q is what actually? Q is this. Log m to the base a. R is what? This. Log n to the base a. Therefore we have got a wonderful result in logarithms. Log mn to the base a is equal to log m to the base a plus log n to the base a. But dear students, remember that many students will confuse. They will write that log m plus n to the base a as something like log m to the base a plus log n to the base a. That is totally wrong. You should not write like that, right? And generalizing this for 3 terms, like log xyz to the base a, you can write as log x to the base a plus log y to the base a plus log z to the base a, right? In the same way we can generalize this for now for n terms, right? Now by generalizing the above result for n terms, log x1, x2, x3 so on up to xn to the base a, we get that as log x1 to the base a plus log x2 to the base a plus log x3 to the base a so on up to log xn to the base a. Like this we can generalize this for n terms. Logarithm of product of different terms to the base a will give logarithm of their sum when the terms are taken individually. Now like that we have fifth result, log m by n to the base a, that as log m to the base a minus log n to the base a. How we are going to prove? Let us take left hand side log m by n to the base a, you take it as p. By converting that into exponential form, a power p is equal to m by n, and take log m to the base a as q. From that, a power q is equal to m, and you take log n to the base a as r. From that, a power r is equal to n. Now a power p equal to m by n, that equal to a power q by a power r, that is a power q minus r. Now bases are equal, you can equate the powers, p equal to q minus r. That means p you have taken log m by n to the base a, that equal to q log m to the base a minus log n to the base a. Like this we have got this wonderful result. Now the sixth result, my dear students, log m power n to the base a is equal to n into log m to the base a. How we prove that? You take left hand side, that is log m power n to the base a is equal to p. That means when you convert into the exponential form, a power p is equal to m power n. That means, okay, let us take log m to the base a, this log m to the base a as q. Now after converting into exponential form, a power q is equal to m. Now let us take what we have taken, a power p is equal to m power n, and m is here a power q whole power n, that is a power qn, like that. Now a power p equal to a power qn, hence here the bases are equal, you can equate the exponents, that means p is equal to nq. Therefore p means actually what we have took, log m power n to the base a, that is equal to n into q. Q is what, right? Q is what? We have got log m to the base a. Log m power n to the base a equal to n into log m to the base a. Like this we will prove this wonderful result, my dear students. Next we have got one more result that similar to this kind, like log m to the base a power n. Here the power n is to the base, that equal to 1 by n into log m to the base a. This also can be proved similar to the sixth result. You take log m to the base a power n as p. Now you convert that into exponential form, then a power n whole power p is equal to m. That means a power np equal to m, right? A power np equal to m, right? Now you take log m to the base a as q. That means a power q is equal to m. A power q equal to m, right? Now you know a power np equal to m, that equal to a power q. Now here also both you have, okay, both are equal, the bases are equal, you can equate the powers, exponents. That means np equal to q, p equal to 1 by n into q, like this. Therefore p is here log m to the base a power n is equal to 1 by n into log m to the base a. Log m to the base a power n is equal to 1 by n into log m to the base a. In this way we will be proving this particular result. Now we have got another subsequent result based on the previous results. Let us name this as eighth one. Log a power m to the base b power n, this equal to m by n into log a to the base b. How we got this? Let us prove it. Okay. Now we have here left hand side log a power m to the base b power n, that equal to, we know that by the sixth result, this we can write as m into log a to the base b power n, right? That equal to m into, and again this is by seventh result we can write that m into 1 by n into log a to the base b. That means m into 1 by n is now m by n into log a to the base b, that is equal to the right hand side part. In this way we can prove this particular nice result, right? Now, dear students, the ninth one, which is change of base of logarithm, which is very important while doing logarithmic problems. The result is log a to the base b is equal to log a to the base c into log c to the base b, where the bases b and c are not equal to 1 and a, b, c are positive real numbers. Those are the conditions which are required to get the logarithm of a number. Now, we will prove that. Let us take the right hand side part first, my dear students, that is okay, log a to the base c. First you try that and that as m. Now you convert that into exponential form, you will get c power m is equal to a, right? And you take log c to the base b as n. From that, b power n is equal to c. You will get this, you call it as equation number 2 and this as first one, equation number 1. Now from 1 and 2, we know that a is equal to c power m and c is equal to b power n. That's why now in the place of c you substitute b power n. A equal to c power m, that is now b power n whole power m, that is b power mn. Right? Now let us take b power mn is equal to a, we have got. You convert that into logarithmic form. That means log a to the base b equal to mn. M means what you have taken? Log a to the base c into n means what? Log c to the base b. Therefore log a to the base b, you got it as log a to the base c into log c to the base b. Right? That is what the result we require to prove. Now, in the same way, my dear students, you can prove log a to the base b as log a to the base c into log c to the base d and log d to the base b. Here you have introduced d also another variable than the ninth result. Like we can introduce some other variables to change the base of the logarithm like this. And also log a to the base b, you can even write log a to the base c into log c to the base d into log d to the base e into log e to the base b. Here you introduce c, d, e, right? This is also correct. These proofs also can be proved in the same fashion how we proved this ninth result. It's a very important result, right, my dear students? You observe. Now, my dear students, under this we have got some corollaries. Log a to the base b equal to log a to the base c into log c to the base b. That is what our result, what we have proved in the beginning. Now log a to the base c, this is equal to, if you subject this, you get log a to the base b by log c to the base b, right? Log a to the base b by log c to the base b. That means that as an example, even we can say that suppose you have log something like 2 to the base 3. This you can write as, you can introduce some other variable, log 2 to the base 5 by log 3 to the base 5. Like that we can introduce, right, some other variable and we can write it like this. And also one more thing we are going to get from this is a very wonderful thing, like if you take b is equal to a in 1, if you take b equal to a, this become log a to the base a, because you took b equal to a. Now this become log a to the base c into log c to the base a, right? And log a to the base a become what? 1. From that you will get log a to the base c is equal to 1 by log c to the base a, and log c to the base a equal to 1 by log a to the base c. That means they both are reciprocals to each other. We have got that log a to the base c and log c to the base a both are reciprocals to each other and their product is nothing but 1, right? Like this we have got some important and wonderful results on this change of base of logarithm. Now we have based on our previous result, combining all those things, we have got this different thing. How we are going to get this, you please observe. Log this you can write it as something like x power n, because we know that x power n to the base a power q plus log y power m to the base a power q plus log z power p to the base a power q, like this we have, like this. And this is further we know that we can write it as n by q into log x to the base a plus m by q into log y to the base a, right? And this is p by q into log z to the base a. Like this we can write this problem, right? Like that we have many more things, like suppose you have that log mn, right? Log mn, log mn by p to the base a. Suppose if you have like this is also can be written as like this. You observe, this is now log mn to the base a minus log p to the base a, and this becomes now log m to the base a, right, plus log n to the base a minus log p to the base a. Like this we have got some very interesting results based on our previous results. Like that, one more we have the 12th one, that is log xyz by pqr whole power n to the base a, right? Something, okay, based on our previous result. This we can write it as something like n into log of xyz by pqr to the base a, because you know that some result log m power n to the base a is n into log m to the base a. In the place of m you have now xyz by pqr. Now this further we can write that n into log xyz to the base a minus this total, n is for this total, log pqr to the base a, right? Now this equal to n times of right, we have got this, we can write it as log x to the base a plus log y to the base a plus log z to the base a minus this is now log p to the base a plus log q to the base a plus log r to the base a. In this way we have got some fascinating results on these logarithms. Now we are going to do certain problems, right? Those will give you a better idea of how to tackle the logarithms, and our main intention in this topic is to do logarithms and logarithmic inequalities. Now a wonderful problem based on our logarithms results what we have discussed immediately. If m, n, p are positive reals different from 1, find the value of log m power 4 to the base n cube into log n power 5 to the base p power 6 into log p power 7 to the base m power 5. This, my dear students, how we will perform this particular problem is, you take left hand side, that you can write it as 4 by 3. This is now log m power 4 to the base n cube, you can write as 4 by 3 into log m to the base n into 5 by 6 into log n to the base p into 7 by 5 into log p to the base m. Like this we can write. And this 5 and 5 will cancel, 4 into 7, 28 by 18, and we can cancel even further, 2 9s to 14, 14 by 9, and this become log m by n into log n by log m to the base n into log n to the base p into log p to the base m, like this, right? And you know, my dear students, this totally m to the base n, n to the base p, p to the base m, you have that, you can write as log m to the base m by change of base of logarithm concept. 14 by n, 14 by 9 you have got, and log m to the base m is 1, because you know that log of any number to the same base is nothing but 1, like this. Therefore this is 14 by 9, and the answer is 14 by 9 in this case. Okay, my dear students, this is the problem. The second problem, if 5.6 whole power x is equal to 0.0056 whole power y is equal to 10 power 5, then show that 1 by x minus 1 by y is equal to 3 by 5. This is the problem. You observe how we are going to do this particular problem. Now let us take this 5.6 whole power x as 10 power 5, right? It is given, the first one. Let us convert this into the right exponential form. That means we will get log 10 power 5 to the base, right, 5.6 is equal to x, we will be getting this. Just you converted this into exponential form. Log 10 power 5 to the base 5.6 is equal to x. This you can write it as 5 into log 10 to the base 5.6 is equal to x, right? And my dear students, from that you know that log 10 to the base 5.6 is equal to, you can write it as x by 5. And from this, once again, by 5 by x by this reciprocal, by taking the reciprocal, you know that this we can write it as log 5.6 to the base 10 by taking the reciprocals, because we know that log a to the base b is equal to 1 by log b to the base a. They are reciprocals to each other, and we can write it as, right, as I told you once again, log a to the base b you can write as 1 by log b to the base a. By like this we have written, right? Fine. Now in the same way, my dear students, here you got another one, 0.0056 whole power y. This is equal to 10 power 5. Now you take this log 10 power 5, you convert that into exponential form. Now 10 power 5 to the base, right, 0.0056 is equal to y. And you see this you can write it as 5 into log 10 to the base 0.0056. This is equal to y, you can write, right? Once we have got like that, we can write this as log 10 to the base 0.0056 is equal to y power 5, we can write. And in the same mechanism we apply here. Now you take the reciprocals, that means 5 by y is equal to log, you can write this, my dear students, 0.0056 to the base 10. And of course this even you can write this as, right, like that, log 5.6 whole cube, okay, this log, how we can, now dear students, we have got, now we need to prove 1 by x minus 1 by y equal to 3 by 5. That's why we have got now 5 by x equal to this and 5 by y equal to this. Now let us write 5 by x minus 5 by y, that is equal to log 5.6 to the base 10 minus log 0.0056 to the base 10. You have here like this. And of course you can write this as log 5.6 by 0.0056 to the base 10. That is nothing but, my dear students, you can write that log, you know that, you can write this as like, fine, this as this particular step, 5 by x minus 5 by y, log 5.6 to the base 10 minus log 0.0056 to the base 10. Log m minus log n, that we can write as log 5.6 by 0.0056 to the base 10. Right, and you can cancel this, right, by multiplying 10 cube on both sides. You will get 5.6 and 5.6. If you multiply 10 cube on 10 cube, that, and you can cancel that, then you will have that log 10 cube to the base 10, that is 3 into log 10 to the base 10, that is 3. Log 10 to the base 10 is 1. Now you have got 5. If you take common, 1 by x minus 1 by y is equal to 3. That means 1 by x minus 1 by y is equal to 3 by 5. 1 by x minus 1 by y is equal to, you got it as 3 by 5. In this way, this beautiful problem we can solve. My dear students, you have got, right, each one we have taken separately, converted into logarithmic form, and we got 5 by x and 5 by y. We subtracted, from that we got 5.6 by 0.0056 is nothing but 1000. Log 1000 to the base 10 is 3, log 10 to the base 10, that is 3. Therefore 5, if you take common, 1 by x minus 1 by y is equal to 3. Therefore 1 by x minus 1 by y is equal to 3 by 5. Now another interesting problem. Show that log 2 to the base 5 lies between 1 by 3 and 1 by 2. Right? How we will do that is, this is what we require to prove, like log 2 to the base 5 lies between 1 by 3 and 1 by 2. My dear students, we can write, right? We know that one thing here, how we will be doing it, right? 1 by 3 we can write as log 5 power 1 by 3 to the base 5, okay? Because you know that that is 1 by 3 into log 5 to the base 5, that become 1 by 3. And you have log 2 to the base 5 as it is, and 1 by 2 you can write as log 5 power 1 by 2 to the base 5. Now you observe, my dear students, everything now log 5 power 1 by 2 to the base 5, log 2 to the base 5, log 5 power 1 by 2 to the base 5, and here the base 5 is greater than 1 and it is positive. Then it will maintain the inequality. This 5 power 1 by 3 we can write as cubed root of 5 is less than 2 less than square root of 5. And this is fact in mathematics. This is fact in mathematics. Cubed root of 5 value is less than 2 and that is less than square root of 5, right? By sorts you know that it is true. Therefore my dear students, once this is true, that means this is true. Once this is true, that is true. This is true. That means our problem is proved now. 1 by 3 less than log 2 to the base 5 less than 1 by 2 become true. Like this we can do this particular result like this. And you know that this is true. How means, you know, in our sorts. How this is true. Now I am giving a clear picture in sorts. We know how to arrange ascending and descending order, which is greater, which is lesser in sorts. You know, 5 power 1 by 3, 2 power 1 you have here, 5 power 1 by 2. If you observe this, this is like 1 by 1, right? 1 by 3, 1 by 1, 1 by 2. The LCM of 3 and 2 is 6. Now what you do is 5 power 1 by 3, 1 by 3 you multiply and divide by 2. And here this LCM is 6, you multiply and divide by 6. For this 5 power 1 by 2 you multiply and divide by 3. Therefore you got, dear students, 5 power 2 by 6 and this is 2 power 6 by 6 and this is 5 power 3 by 6. And this is nothing but 6th root of 5 square. 5 square is what? 25. And this is 6th root of 2 power 6, that is 64. And this is 6th root of, right, 5 cube, that is 6th root of 125. And you know that once the orders are same, you can compare the radicands inside like this. That means, you see, this is 25, 6th root of 25 is less than 6th root of 64 is less than 6th root of 125. That means this is true. This is true means this is true. This is true means, right, like this, this particular interesting problem can be proved, right? Now, one more interesting problem, my dear students, the fourth one and the last problem of this video. If x is equal to log bc to the base a and y is equal to log ca to the base b, z is equal to log ab to the base c, then show that 1 by x plus 1 plus 1 by y plus 1 plus 1 by z plus 1 is equal to 1. Now here you take x plus 1. X is given log bc to the base a plus 1, that equal to log bc to the base a plus log a to the base a. That is log m plus log n is log mn to the base a, like log abc to the base a. In the same way we can write y plus 1. Y is log ca to the base b plus 1, right? And this is now log ca to the base b plus 1 we can write as log b to the base b. Now this become log abc to the base b, right? In the same way now z plus 1, this is z is log ab to the base b, ab to the base c plus 1. That is now log ab to the base c plus log c to the base c. This one we can write like this. Now this is now by the formula log abc to the base c we can write. Now the left hand side we have, that is now 1 by x plus 1 plus 1 by y plus 1 plus 1 by z plus 1. That is 1 by log abc to the base a plus 1 by log abc to the base b plus 1 by log abc to the base c you can write. And you know that we know in logarithms, right? We know that log a to the base b is equal to 1 by log b to the base a. By using that, we will get this become now log a to the base abc plus log b to the base abc plus log c to the base abc, like this. And this total, log x plus log y plus log z to the same base abc, that become log x. In the same way, like log a b to the base abc, that become 1, because logarithm of any number to the same base will become 1, right? That's why we have got this problem, my dear students, and we will upload many interesting videos on these logarithms and logarithmic inequalities. Do subscribe to this channel such that you will get more and more videos. Thank you very much for watching.